We are on 3-5 arithmetic sequences as linear functions. Page 193, number 20. So number 20. It says, write an equation for the nth term of the arithmetic sequence, then graph the first 5 terms in this sequence. So here are our values. So our values are negative 11, negative 15, negative 19, negative 23, dot, dot, dot. These are our values. These are our page 193, number 20. Terms. So I'm going to go ahead and I'm going to create this into a table. I got 1, 2, 3, 4, so on and so forth. I have my 2 points. So this would be negative 11, negative 15 minus negative 11, 2 minus 1, so that gives me negative 4 over 1. So I know that I am counting by negative 4. Negative 4 is my slope. So I'm going to use a point. So y minus negative 11 equals negative 4x minus 1, turns into plus 1. Y plus 11 equals negative 4x plus 4. Subtract 11, y equals negative 4x minus 7. There's my equation. Now they want it as an nth term, so I just need to translate this into a sub n equals negative 4n minus 7. There is my equation. It says go ahead and graph the first 5 terms of the sequence. Now let me double check something, because on page 262 I have page 262, number 23, when we get there, number 23. Yep, okay. So we're going to go ahead and graph this. So these are my values, these are my terms. So I need to graph the first 5. So I know I start at negative 7, and what's going to happen is I'm going to keep going downward. So I need to graph the first 5, 0, 1, 2, 3, 4, 5. I'm going to graph the first 5 values. Now I know that I start at negative 7. If I'm starting at negative 7 and I'm going down by 4. So I can count by 4 if I want, or 5, it doesn't matter. So negative 7, let's count by 5. Actually, this will be easier. Let's start at negative 5 and count by 5. So that would be negative 5, negative 10, negative 15, negative 20, negative 25, negative 30, negative 35, negative 40, so on and so forth. So my first term is negative 11. Negative 11 is about here. My second term is negative 15. My third term is negative 19. My fourth term is negative 23. And my fifth term would have to be negative 27. Negative 27. Beautiful. There are my first 5 graphed. And I skipped a bunch of values, so that's what it would look like. There we go. Page 243, number 27. Page 243, number 27. I need to find an equation that is perpendicular to this point, or go through this point and is perpendicular to this line. So it needs to go through this point, 3, 8, and it needs to be perpendicular to y equals 5x minus 3. Perpendicular means the opposite inverse. So my slope will turn into negative 1 over 5. And it needs to go through this point. So there's my point slope. So y minus 8 equals negative 1/5 x minus 3. Y minus 8 equals negative 1 over 5x. Negative times negative is a positive, 3 over 5. I'm going to multiply everything by 5 since I already have a fraction. 5y minus 40 equals negative 1x plus 3. I'm going to add 40, 5y equals negative 1x plus 43. And I'm going to go ahead and I'm going to divide by 5. Y equals negative 1 over 5x plus 43 over 5. Two more problems. Page 22, number 16. 220, number 16. Okay? So this time we are not going to graph. We just want to find the equation because I'm not going to be able to graph because I only gave you one graph. So here we go. Anna is driving from her home in Miami, Florida, and her grandmother's house in New York City. On the first day, she will travel 240 miles to Orlando to pick up her cousin. Then they will travel 350 miles each day. Write an equation that models the total number of miles M Anna has traveled if D represents the number of days after she picks up her cousin. So, where does she start? She traveled 240 to begin with, so that needs to be my y-intercept. And then every day she travels 350, so that would be my slope. Now, they want us to use M and D, so M would stand for miles, that's my y. D stands for days, because I knew X stood for days, so that's my new equation. I can't graph it because I didn't give you a graph. We graphed the first one. I can't graph this right now. So now it says, letter C, how long will the drive take if the total length of the trip is 1,343? If the total trip, so this time I have to plug in 1343 into my miles. I need to figure out how many days. So I need to solve for D. So I'm going to subtract 240, subtract 240. So I have, subtract 240, so 1343 minus 240 gives me 1103, 350D. If I divide by 350, I get 3.15. So it's going to take her 3.15 days, a little over 3 days to travel that many miles. We got one more problem. I'm going to do this up here for some room, page 262. I apologize for not giving you a graph. Page 262. Page 262, number 23. It says, Gina wants to buy a specific make and model of a used car. So it says, describe the relationship in the data. So my letter A, if I describe the relationship in letter A, what I'm going to go ahead and do, so what's happening? So my X, my age, so as my years increase, my price of the car decrease. So the older the car gets, the less it's going to cost. Okay, so that's what I did. Letter B says, use a line of fit to predict the car that is 7 years old. So here we go. Letter B, I need to predict at 7 years. Now, I've taught you to come up with an equation. Now, I don't have to come up with an equation if they already give me 7 years on the graph. If I look at 7, and I go up to my line, that's going to be about $3,000, maybe $800. So I don't need to come up with the equation. If they show it to me on the graph, $3,800. That's how much it'll cost around 7 years. Letter C says, is it reasonable to use this line of fit to predict the price of a 10-year-old car? And we would say, not really, because it would be free. And what I mean by that is if you guys look at 10, 10 would be here, that's 0. Well, the car is going to be worth something, it's not going to be 0, and that's what they're trying to get at. It won't be 0. And we are done.